Alrighty, ladies and gentlemen, welcome to our next lesson in Big Ideas. It's our last lesson of Unit 3 and Unit 12, respectively. Lesson 3.4, page 128 for my 8 general students, and Lesson 12.4, page 552 for the 7th Accelerated, where we are going to continue to apply what we learned and use similar triangles to solve real-life problems. Our essential question, how can you use angles to tell whether triangles are similar? And of course, as always, ladies and gentlemen, make sure that you are autographing your notes with excellence. Take notes that you are able to use. Your notes are a tool to help you learn and understand. Ladies and gentlemen, being a person of character and intelligence requires that you take the notes from the book first. That is the principle of intelligence of self-teaching. Teaching yourself a little bit. You may or may not fully understand from taking the notes from the book. That is why we then get together and we do these videos and we talk about that stuff to help you gain even more understanding. And then when you come to class and we revisit our notes, we should be gaining even more of an understanding as we revisit those notes. Ladies and gentlemen, so you should have taken some notes from the top of page 128 or 552 respectively. And of course, I am going to mention once again, as I've mentioned many times, I talk fast, I write fast. To do that helps keep these videos at as short as length as possible. But unfortunately, it's a little bit too fast for many of you. So you must put your pencil down, watch, listen, learn, then pause and write down the information. That even gives you a fourth time of revisiting the information because you have to rehash it in your head as you are copying it from the video, ladies and gentlemen. So, we're going to review real quickly similar figures. We've learned about similar figures before. We happen to know that these are triangles. And I know you took some notes, but we're going to talk about similar figures first. So we remember that in similar figures, we have the same shape. Well, that same shape today is triangles. Our same shape today is triangles. That's our same shape. And then it says the corresponding angles are congruent. That is key to what we're doing today and what you already wrote down. And then we know that the corresponding sides are proportional. That's also going to help us today in what we're going to be doing. So what did you write down? You wrote down that if you have two triangles and two of the angles are congruent. So this triangle ABC, I have these two angles, 65 and 95. If I have another triangle, say DEF, and that triangle has 65 and 95 as angles, if I have two angles that are congruent, the third angle must be congruent. And if so, we have similar triangles. Well, that's important because if we can prove we have similar triangles, then we can come over here and use corresponding sides that are proportional to solve some of these real world problems we're going to be talking about today. So that's important. And of course, our similarity statement says the triangle ABC is similar. Remember that little wavy line means that they are similar. So of course, the key words that you wrote down is if we have two angles that are congruent, the third angle must be congruent. And if all three angles are congruent, we have similar figures. If we have similar figures, we can use the corresponding sides that are proportional to help us do what we're going to do. So the first thing we're going to do is we're going to find out, do we have similar triangles or not? Finding similar triangles, telling whether these triangles are similar, and using what we just talked about with the angles. We know we have the same shape. We have triangles. Okay. And now with these triangles, we take a look. I can immediately recognize that I have these two angles that are congruent, the right angle. So I know I have two right angled triangles. Now I need to find out, do I have another congruent angle? Well, in this particular case, we know that 43 and 47 are not the same. So I've got to say, is angle X equal to angle 47, or is angle Y equal to angle 43? We only need to prove one of those. Doesn't matter which one. So I'm going to take the first triangle and I'm going to use what we know about triangles that we learned a little while ago. And I'm going to add the angles together. X plus 90 plus 43. And we know that the sum of the interior angles for a triangle is 180 degrees. If not, we use that formula that the sum is equal to 180 times n minus 2, the number of sides minus 2. But anyway, So now we have x. When we simplify this together, x plus 133, whoops, 133 is equal to 180. And then when I subtract 133, I get that x is equal to 47 degrees. Well, if x is 47 degrees, then is it similar, or excuse me, is it congruent to the corresponding angle in the other one? And the answer to that is yes. So the answer is yes. We have similar triangles right here. These triangles are similar. Trying it one more time, telling you whether triangles are similar and explain. And of course, we take a quick look. Hey, I've got these two angles that are congruent. We have one pair of angles that are congruent. We need to find another. And again, we need to decide, is this angle x congruent to angle 59, or is this angle y congruent to angle 58? And again, it doesn't matter which one you choose to do, doesn't matter. So I'm always partial to the x, so I'm going to use that triangle, and I'm going to go x plus 58 plus 43 equals our 180. And when I simplify, 48 plus 53 is 101. So x plus 101 is equal to 180. And then I subtract the 101. And I get that x is equal to 79. Well, this right here is not 79. So no, not similar. All right, moving right along. Telling whether the triangles are similar. This is our last example of the first video. And again, we recognize that there are two angles that are congruent. This angle 52. We already have that one. Bingo. So I've got to decide, is x congruent to 80? Is y congruent to 48? And again, makes no difference. You know me. I'm going to go with the triangle with x in it. Plus 52 plus 48 equals 180. Simplifying, 52 plus 48 is 100. And that is equal to 180. And then when I subtract the 100, I get that x is equal to 80. And if I look here, x congruent with 80, and the answer is yes. These are similar. These triangles are similar. By using the angles that we just learned about, if we have two that are congruent, the third one has to be congruent. If all three are congruent, we have similar figures. Ladies and gentlemen, our first quick write. If you would please make two rough drawings of these very quickly, label all the angles, and then use what we just did and practice and see if you understand how to tell if these two triangles are similar. Go ahead and take a quick break and then come back and join me for our second video of the night.